prepared just in case. All right, so we should have our notes out. And we're on page 18. And our job is to factor and sketch. Who can remember what we do? What is our strategy here when we have to factor and sketch this thing?
Guess and check.
Guess. We're going to guess and divide, right? We're going to guess and divide. And because this does not factor by grouping, right? Can you see that? That it doesn't factor? That 11 kind of messes everything up. So I'm going to list my possible rational groups. Who remembers where they come from? Lila?
The factors of the last number of the
Factors of the last number, which are 6. So what are the factors of 6? Always plus or minus.
3.
Plus or minus 3, 2, 1, and 6. Those are the factors of 6. Over the factors of the first number, which we love it when it's just 1. It doesn't have to be 1, but it is, so we'll take it. How many numbers are in that list?
4.
8. There's 8 numbers in that list. Plus or minus 4, or plus or minus 3, plus or minus 1, 2, and 6, right? There's 8 numbers in that list. So now we're going to guess one. Pick a number in the list. 2. Put it in the box. And do the division. So that is just a totally random guess. We just pick one, put it in the box, and divide. So let's see what happens. Multiply, put the answer here, and add. Oh, this looks good. Multiply, put the answer here. Oh, shoot. Not, oh yeah, no, that did work. Yay, that worked. What happens if it doesn't? What happens if this is something other than 0? Try again. Pick a different number. Try again. You don't have to erase it. You just have to squeeze it in somewhere. Try another one. But we got it. So that means in terms of my graph, that number is one of my x-intercepts. So the number in the box is a dot. If we wanted to list the factors, this would be the factor. That would be the factor. That would give me that number as a dot. Now, how many more dots should there be? 2. Where are they gonna come from? This guy right here. What is he? What does he say? Okay, what was this? This was 1 x cubed. So what's this?
X cubed.
No. Always go down a power. You divide it. So you divide it. So this is going to be x squared minus 4x plus 3. And what can we do with that? Factor. How does that factor?
1 is x minus or x plus 3, x plus 1.
X minus 3, x minus 1.
Get negative 4.
Which means, where are the other 2 dots? At 1. And where's the other one? 3. So we guessed that one. We factored factor to get these two. So there are our factors. Here are our dots. Now I need to draw the picture. How many X's do I have? 3? Where do odd, 3 is odd. Where do odds start? Down? Is anything squared or anything? No. So we just start down here. And then we go through and connect. Go through and connect. Go through. And there we go. That's a lot. All one problem. Okay. You're really good with that? Because we're going to do it again. Alright, here's the next one. This one, I remember from years past, has sometimes caused us to ask some questions. Because kids will say, hey, I can group this. I can take out an x squared and have x plus 4. That is true. True. I can take out a negative 3 and have x plus 6. That is true. True. But what? They don't match. And if they don't match, if these guys don't match, you can't go on in the problem. It ends here. So this problem, while you certainly can do some factoring, it does not factor by grouping. All right, remember, if factoring by grouping is going to be your thing, these must match exactly. They don't. So, my friends, can't factor by grouping. What do we have to do?
Yes.
Guess and divide. That's right, we're gonna guess and divide. What are our PRRs this time? Possible, that's the key word. These are your possible rational groups. What are they?
Plus or
Factors-
minus 2, 1, 4.
Factors of 18?
Oh, of 18.
Always
6.
factors of last.
2.
So 1, 2, 3, 6, 9, and 18. Did I get them all? Those can be in any order, but you do need the plus or minus. And then again, we are super lucky. That's a 1. All right, so we're gonna guess. What do you want to guess? Pick one.
3.
3? I'm gonna put a 3 in the box. Whatever you're guessing, then put that in the box. And what do we hope happens?
To get a 0 here.
This guy right here, we want to be a 0. So drop our 1 straight down. Uh-oh. I don't think we got this one, do you? We don't even care what those numbers are. We need that to be a 0, and if that isn't gonna be a 0, it doesn't really matter. Okay, well 3 didn't work. What, you wanna try negative 3?
Yes.
You don't have to, we gotta pick another number. I'll try negative 3. Okay, so what does that mean? The fact that I got negative 3 means that when I draw my picture, there's going to be an x-intercept at -3.
Yeah.
Now, there are gonna be a couple more x-intercepts. One of the cool things about polynomials is whatever the degree is, whatever that is, that's how many roots you have. So I have 3 roots. I got 1, I guessed 1. Where do I go from here then? Look at the last problem, guys. What did we do? Where did we focus our attention? On this right here? Because what is that? It's the quotient, but what is it? X squared plus x minus 6. Remember, the original was x cubed. We did a division. That dropped it down to x squared. Now, what can you tell me about x squared plus x minus 6?
X minus 2, x plus 3.
I heard an x plus 3 and an x minus 2. Can I double check that if I want to know for sure?
Yes.
I foiled it right. That's how I double check it. I think it's right. So what does that mean? That, uh-oh, wait a second, time out. This would mean I had a dot at, but wait a minute, I already have a dot there because of the number that I guessed.
Yeah.
So that means that factor is squared?
Yeah.
Because that dot happened twice?
Oh, yeah.
And then I have 1 at 2. This guess gave me a dot at -3.
Oh, it's gonna be negative.
Then when I worked it out, I got another dot at -3. So I have 2 dots at -3. Now, how does that change things in terms of my picture, Isaiah?
Start up.
Well, it's a cube. It's a cube. The cubes are gonna start down here. That's where cubes are gonna start. But what's it gonna do when it hits this dot?
It's gonna bounce.
It's gonna bounce right down and connect to that one. Why does it bounce off there? Because it's a squared factor, and that's what squared factors do. Always. They make like a parabola. All right. I'm not going to say anything for a couple minutes. I want you, this is the same kind of problem. Same exact kind of problem. You and your partner go ahead and see if you can make any progress on this guy. Start by listing your PRO. This problem is kind of nice. Cause what are your only PRRs?
1 and 7.
Plus or minus 1 and 7?
Yeah.
So you only have 4 potential numbers. So hopefully you'll guess one pretty quick.
I have a question.
Let's try the other one.
When you find your PRR, do you represent it as like X plus whatever? Or X minus
No,
whatever?
you just make a list of numbers.
No, I know, I already found it, but I'm
Right.
saying, would it be like the first point? How do I know if it would be to the right or the left? If it's positive or negative? Or
Yeah.
Okay.
Positive 7 is plotted over here.
Okay.
You plot the number in the box when you do the division. So if there's a 3 in the box, you plot 3. If there's a -2 in the box, you plot -2. You plot the number in the box. Okay, so anybody find one?
Yeah.
What worked? 7? So I'll try 7 since you already told me it worked. Sure did, good job. Now, what does that mean? That means for my picture, that one of my x-intercepts is at 7. Now, where am I going to find the other ones? X squared minus 2x plus 1 is what's called my depressed polynomial. That's my quotient. How does that factor?
X minus 1, X minus 1.
X minus 1 minus 1? Is that right? Negative x, negative x. Now wait a second. There's a dot at 1, but that dot actually happens twice, which means that factor is squared. The factor with the 7 is not squared, it's just a regular factor, but that one's squared because it happened twice. All right, so I'm gonna start down here. Why am I starting down here? Because it's an x cubed, and where do x cubes start? Down here. Now what am I gonna do when I hit this 1? Bounce off, connect, and what am I gonna do when I hit the 7? Straight on through. I don't bounce at 7, right?
1 also worked too, I think. Like just positive 1.
Yeah, that's what this is.
Oh, okay.
So you could have guessed 1
Yeah.
and said 7. I said 7 because somebody suggested it, but
Okay.
yeah. 1 and 7 are the 2 numbers that work. Negative 1 and negative 7 won't work in this problem. Now, Brian, if you guessed 1, then your thing here was different,
Yeah.
but it factored into x minus 1, x minus 7. So you got exactly the same thing in a different order. Okay? All right, I'm gonna make one up here real quick, and I want a volunteer to come up and do it at the board. You should have a little bit of room there to do it, maybe. All right, so here's one. I need a volunteer to come up and do it on the board. I'm not gonna do any of this. So you can come up with a friend, or you can come up by yourself. But I need you to factor and sketch it. Here it is. hands. You guys are good, you're always up for it. Instead of being a slug sitting here doing nothing, come on, get busy. Walk in. It's our last math class for a week. I haven't seen them already.
What is your, like, the little sister's here.
I did.
What was it, record? I heard it's
Come on, write it down, don't just sit there. We're not on vacation, come on, guys. You just follow down and
So for the synthetic division, when we're doing it, it's not an automatic subtraction. It's just like if these are the changes.
yeah, no, it's an ad, that's an ad.
Okay.
Two times negative 3 is negative 6.
Whoa, what happened to your size? No, your size is there's the independent way.
I don't know, someone made it.
They call you a field tennis player? They call you no, they call you a field tennis player.
Alright, keep guessing. Okay, we're guessing, everybody's guessing. And when do you stop guessing? When you get a 0.
Will our quiz be over this? As like our next quiz?
Oh, yeah.
It'll go over this and like something just like.
No.
Everybody getting away. Well, but like we go through a bunch of stuff.
Be quiet.
Oh, you wrote it.
I'll be the one. I think you wrote that down wrong, but I don't know.
Alright, so they found that 2 was one of the roots. So they're gonna graph that. not sure where you started up here.
Oh, I start.
Don't start up there.
Here's a play.
Now, looks like they're factoring what they have left. Have you done this problem, Pippins? If I walk back there, I'm gonna see it.
Next.
It's a pedal.
All right, let's look at what the kids came up with up here. They got,
I was saying all business.
for their zeros, their intercepts, they got -1, +2, and +3. Right? You label those guys, get in the habit of labeling those. It is. So we gotta have them labeled. And then, how do you like your connection of the dots? What do you think about that?
I got it.
That is perfect. Okay? Now, we are, 2.4 is due on Monday. 2.4 homework will be due on Monday. That's a week from today. We are gonna continue plowing through 2.5, as far as we can. But on Monday, we will do a practice quiz. And then our next class after that, Tuesday or Wednesday, depending on what it is, we'll have an actual quiz over all this kind of stuff. Okay? So, here we go. That's a good practice problem. Hopefully, everybody participated, because that's the only way we get good. And let's jump in and do some synthetic division practice. Well, this looks easy enough. 2.5, number 5. I am going to simply do a division. Now, listen carefully. This problem is a trick. Do you notice that we have a 2x to the 4th, but we don't have an x cubed? We have 3x squared, -9x, and 1. When you are doing synthetic division, actually any kind of division, but especially synthetic division, if a power is missing, see how it goes from x4 to x2?
Yep.
3 is missing. When a power is missing, you have to put in a 0 for it. Okay, if 2 powers were missing, we put in 2 zeros. And then just do division like usual. So, here we go.
Why did you put a 2 there?
You're right.
On the top left.
Isn't that what?
I thought it was -2.
You change the sign.
We always do the opposite. When we take a number, don't act surprised, Brian, that's how we've been doing it. Okay, lock in, okay. When we take a number out of the parentheses, it's opposite, every time. When we put a number into parentheses, it's opposite, every time. So here we go. Now, remember, all I'm doing is dividing. Clearly, this is not a factor. Hopefully, did I multiply right and everything? This is not a factor. How come? How do I know? I didn't get a 0 out there. That number's the remainder. So what's my answer? I did a division. What's my answer? 2x to the third plus 4x squared plus 11x plus 13.
Yeah.
And then this guy that I want to be 0 normally, because that's the remainder, and when the remainder's 0, it means I have a factor. Well, that's my remainder. So 27 over x minus 2. Now, before you say, well, you write that way, stop and think about regular division. When you do regular division of numbers, put a 2 up here and subtract, right? And what does that mean? 2 and 1/5? So 2 all of this and 27 over what I divided by. So this is the quotient, and this is the remainder. The quotient and the remainder. All right, let's find the quotient and the remainder for B. What's gonna go in the box for problem 5B? -1. Any powers missing in this one? Nope, so I'm just gonna write down all the numbers. No powers are missing, so I don't need to worry about any zeros. And then here we go. Okay, you don't need to do any cheers now. Save those for tomorrow morning. We can do our math cheers tomorrow morning.
Yep. I'll be there right now.
So check my numbers. How's my division look? Those look okay? All right. So now what? I write my quotient and my remainder. And I think actually on test day, I have you separate those. So what's the quotient gonna be? This is the quotient. 3x squared minus 10x plus 19. And then your remainder is -18 over whatever you divided by, which was x plus 1.
Is it different from on the like how do you want us to write our answer?
I think on the test I had you do quotient and remainder separately. Okay? All right, there's one more. Letter C. See if you can do that one. And do I have a volunteer who come up and put it on the board for us? Letter C, and come up with the quotient and the remainder. Thank you. Yeah, 5C. Remember guys, with synthetic division, the first thing you have to pay attention to is, are you missing anything? So, look carefully. You got this done, Mr. Hill? Then what are you doing?
I got too carried away.
Yeah.
It's impossible for. Yeah,
Thank you for paying attention back there.
welcome.
Okay, so now he's gotta write his quotient. So what power is he gonna start with?
X squared.
X squared, one less than the original problem. So 2x squared minus 6x minus 5. And then what is his remainder? Negative 1 over x minus. All right, Joseph? Thank you. Okay. Yes, that's easy to do when you're recopying. All right, so everybody okay with that? All right, I want to pause there for a second and do 2 kind of review problems before we start something else. So, go ahead and get out a sheet of paper, because I don't think you have room on your notes. And I'd like you I'd like you to sketch this thing. Now, we know how to do this. You just have to remember all the different steps we need to go through.
It goes down.
So, who remembers what we do first? Brian?
Sketch the coordinates.
I need to put my intersects on. Now, be really careful. In the homework, some of you are overlooking this guy. What do I do with a plane X?
What, oh, 0?
He's the origin, yep, he's a 0. So if you have a plane X, he's not in a parentheses, but he's an X. Every X gets a dot. If it's not attached to a plus or minus like that, it's just 0. That guy right there is a 0. And then I have one at -2 and 3 and -5. So is everybody with me to here? Now, how many X's, not dots, but actual X's are there in this problem? 1,
4.
2, 3, 4, 5. This is work double, guys. There's 2 of them there.
Yeah.
That's x squared right there.
So we start
So
now.
1, 2, 3, 4, 5 x's.
Yeah.
That is an odd number. 5 is odd. Odds start down here. Except Did you notice that?
Yeah.
So it's the opposite?
So that means I'm gonna start up here. Normally, I would not start up there with an x to the fifth, but it's upside down. Now, what happens at this dot? Bounce, go through, squiggle, what does it do?
Goes through.
It goes through, because that dot came from this factor, and there's no square on that. So this is gonna go through and connect to this one. That one comes from here, so it's gonna bounce right off and connect to that one. That one came from here, no power, so it's gonna go right on through, connect to that one, which has no power, so it goes straight through.
Easy.
Okay?
Easy.
Now, because we're gonna do two. The second one we're gonna do is the backwards of that. So, here is a picture.
Not good.
And you're gonna write the equation. Alright, so we're gonna write the equation for that.
Does it matter what number we put in front of the X? The first
It
X?
does. We've talked about that, Max, let's get to that point, but it does. So let's get to that point. So your job this time is to write that, something that looks like that. So how do you start? What's just logically a
Well-
good beginning step?
X minus 4.
So we'll
it'd
have
be
x
plus
minus 4,
1, X plus 1, X plus 3.
x plus 1, x plus 3,
And then something squared.
and x.
But it's squared.
Now you can put that x anywhere you want, but you have to have a plain x in there. Why do we have to have a plain x?
Could it bounce?
Because we have a dot at the origin. Plain x's are dots at the origin. Now, stand back. Is there any bouncing going on in this problem? There's a bounce
At the one.
here,
And at the
which means this one is squared. There's a bounce here, which means the x is squared. And that's it for bounces?
yeah.
Now, I erased it, but the only thing that's missing is that thing out in front that was a -2 in the last problem. I don't know what it is. I'm gonna give you a random point here. That random point is not gonna be a parentheses, right? What am I gonna do with that random point? I'm gonna plug it in X and Y, and that is gonna figure out this number. Remember doing that?
Yeah.
So here we go. 2 equals that number, I don't know what that number is, but -2 squared, -2 minus 4, -2 plus 1 squared, -2 plus 3. So we're simply plugging in -2 for all the x's and +2 for the one y. All right, do your arithmetic, using your calculator as necessary, and let's see if you can figure out what A is. off and turn out to be ugly fractions, so don't panic. Chase, why's your pencil not moving?
I was just looking at it.
You were looking at it. Anybody got an answer for me? What A did you come up with?
Negative 112.
Negative 112?
Yeah.
Anybody else? I don't know if that's right, I haven't done it yet. I don't know, did I get anything different than that? Everybody got negative 112? Pippins, what'd you get?
I ain't finished.
Okay, you're finished. Kendall, what'd you get?
Negative 112.
Two negative 112s. What's negative 2 squared? 4. What is negative 2 minus 4?
Negative 6.
Negative 2 plus 1
It's
is
negative one.
negative 1, but it's squared, so it's positive 1.
Yep.
And negative 2 plus 3 is also positive 1.
Yes.
So 2 equals, all multiply here, negative 24a. Oh, I think you're right. I think you're right. When I reduce that, I get negative 112.
Yep.
What do I write in the answer blank? Not negative 112.
Y equals
My
negative
equation
4x squared.
is what goes in the answer blank. The negative 112 is part of that, but that's not the answer. Okay?
Yep.
All right, go ahead and get ready. You got work to do. 2.4 is due on Monday, next time I see you. We'll do a practice quiz that day and a real quiz the next day.